My name is Robert, and I'm going to be showing you my project for digital system design at San Jose State University. We're going to be sending UDP packets over Ethernet to my computer, and we're going to be able to read them on the computer using a program called Wireshark. So this is just a demonstration of how to form packets and send them over the internet. You could send them anywhere, in theory, and the concept that we are role playing is a high frequency trader. So today we're using a Zynq 7000 SoC, and so what this means is that our trading algorithm can use programmable logic, which is faster and it can do more types of data processing than a CPU. So we connect the programmable logic to the ARM core in the Zynq SoC with an AXI interconnect. And so the programmable logic takes care of all of the generation of the synthetic data and the digital signal processing, which is our trading algorithm. And then it sends it to a first in, first out buffer. And then the ARM CPU on the Zynq SoC will read from that buffer and create a UDP packet and send it to my computer. So let's check it out. Okay, so I'm just going to frame this as a tutorial. So you start off with this is our HDL block, and so here you can generate synthetic data like a fake stock price, and also hook it up to your trading algorithm. And then the trading algorithm outputs what it wants to do to the buffer right here. This is Xilinx IP. And so you hook up the buffer, make sure you have all the signals necessary. You must get a T-ready signal from the FIFO before it'll accept packets, and then you can send them. And then when we send one packet at a time, and we turn T-valid on at the same time as we send it. So the buffer goes to the AXI interconnect, and the AXI interconnect goes to our ARM CPU. And I could show you the top level layer. Basically, we just have two instances. We have the synthetic data, we have the trader, and we just send out our data packet. We load it into the FIFO. And the market generation is just it's called LSFR, and look that up online, but just sort of like a pseudo random number generator. And our algorithm is just really basic. It's called we're looking for something called EMA crossover, and it's like we're basically just looking for if the stock price is going up or down, and if it's going up, we're just going to buy, and if it's going down, we're going to sell. And it accounts for like a long-term trend and also a short-term trend, and it puts a weight more on the short-term trend. But this is more of a system demonstration, so we'll keep moving. So now we're going to move over to the ARM core, and you can start off with a template called LWIP echo, and it'll take care of a lot of the drivers. So I can show you all the drivers that are necessary for this project. So here, this is the address and memory for the register of our first in, first out buffer. And drivers. We're gonna have two custom functions, helper functions here. And one of them will set up the UDP. It'll set up where the IP address. It'll connect to a port on my PC. This is the default for Wireshark. And the second one will, once like more processing is done in the main block, then it'll call send a trade packet. And send trade packet will basically copy from memory into this function called UDP send, which is is part of a library. So moving on, our main function starts somewhere here. Here's the infinite while loop. So our main function should be, vision isn't that good right now. Anyway, so we're sort of deep into the while loop right now, into the main function here. And the while loop, the infinite while loop is what matters most for embedded systems. And a lot of this is sort of like, I don't know the word for it, but moving on, but like our custom logic is right here. And packets waiting is basically like we're reading a register in the FIFO and saying like, is there data in the FIFO? And there is, then we move on to this logic. And yeah, basically we read in the 32 bits from the trader top that went to the FIFO to here, and we sort of decode it a little bit. Like there's a bit for buy or sell that we decode. Um, and yeah, I think don't want to get in the weeds too much. So let's just do a demonstration. So right now I'm unconnected, and we're just going to run this hardware. And I'll wait on the Ethernet. Okay, so I've plugged in one side of Ethernet to my PC, and I'm going to plug it into my FPGA. You can look at let's open up the Ethernet. We're going to open up Ethernet, and right now there's nothing because I haven't plugged it in yet. Plug it in. Okay, and now we just have, this is the source right here. This is the IP of the FPGA that we manually set, and this is the IP of my computer, and we're getting all of these trading packets. So we can double click one of them, and it says this one is a buy, and like quantity 50, comma, and then the price, saying the price is $13,000. Yeah. And we can just keep looking. You take a look right here. This is the data section of the packet, and these are all like to do with the length and like the source and the destination UDP. And this is the payload right here. And we can just keep scrolling, and it's buying, it's selling, 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 buying, selling. And it goes on and on and on. And it's continuing to generate. See. So I just keeping it constant. This is like one packet, and it just keeps going up and up. See if I can. I have a filter on right now. Usually it shows like much more communication. Like my PC would blast a lot of data to the FPGA saying like, "Are you a router? Like, what kind of device is this?" But I've filtered out all the other IPs except for the IP of the FPGA. So this is a rundown. This is how you can create packets using digital logic. You can and send it to a hardened Ethernet stack, which is much easier than creating your own Ethernet stack in programmable logic. If you created your own, then it would take up probably much of the space on your FPGA, and it wouldn't leave much room for computation. But the advantages of creating your own Ethernet stack is that it would be much faster than this project. There would be lower latency, and that's what And people who actually do this as their business, they would create their own Ethernet stack, networking stack. Okay, so this has been our project. Thank you for watching.